Hey y'all, we are going to look at some quadratic functions. This is actually 3.1 for your homework in the section that we're starting on today. Okay, so a quadratic function. The homework's going to tell you to find the vertex of a parabola. And so there's a few things you need to know. There is a standard form, and the standard form is f of x equals a times x minus h squared plus k. If it wants you to find the vertex, that'll actually be the coordinated point using h and k. Pay special attention there. Our vertex is just the variable h. It's just that value. In our standard form, it needs to be a negative. So I'll show you. Whenever the signs change, it can be very confusing. So I'll make sure I'll show you. Okay, the vertex means whenever our parabola changes direction. And then our symmetry is at x equals h. That is going to be a vertical line going through our x-axis. Now, if our a is greater than 0, that means our parabola opens up. And if our a is less than 0, it means our parabola opens down. You will find the x-intercepts by doing f of x equals 0, and you will find the y-intercepts by doing f of 0. So for the first two, we're literally just going to find the vertex so I can kind of show you what I meant with the signs. So we find the vertex here. My vertex is HK. Looking at the standard form, and it is in standard form, which should be a little bit easier, I noticed that my H value is 1, and my K value is a -1. Okay, so that's it for the vertex. Now, for problem 2, also vertex, it's going to be my H and my K. Y'all, this one, the H is a -6, and my K is a +7. So, and if you look here, that is a +7, so that made sense. What probably didn't make sense was the fact that my H was a -6. Now, the reason being, if we actually compare what's inside of those parentheses and the way the formula shows it, which is x minus h, the way I was going to get from x minus h to x plus 6 would be to do a negative times a negative, right? So following my formula, there's my x, there's my x, there's my negative sign, there's my negative sign. And then right here, that's my h, okay? So that is how my h became, or is, -6. And let me go here. If it tells us to graph this function, there are a few different things that we're going to have to point out first in order to graph it. The good thing is that it is in standard form. Now let's start going through and identifying some stuff. So my A is a 1. So that means that it is greater than 0, which means it's opening upwards. My H is a -5. No, it's a 5. Why do I have that little mark there? That's supposed to be that is x -5 all squared. Okay, so my h is 5, and my k is -9. So this tells me that my vertex, which is where the graph changes direction, is 5, -9. Okay, so I also know that this graph is going to be symmetric at x equals h. And so looking at what I have here, my x equals 5. That's its line of symmetry for this parabola. And then finding the x-intercepts. and the y-intercepts. Okay, so to find these, I'm going to actually come right here, y'all. I'll write the function down again. We have f of x equals x minus 5 squared and negative 9. X-intercept, I was told to do f of x equals 0. And then for my y-intercept, I was told to plug in 0. So if my f of x equals 0, that's me writing this function again, but now instead of f of x, I put 0. And what I have right here in parentheses is x minus 5 squared, negative 9. Okay, so I know how to solve this. I just learned how to do the square root property. And that's actually going to be your best bet here unless you wanted to FOIL and then see, is it factorable using the AC method or, is it a quadratic? Like you kind of aren't really sure, but I am really sure that I do see that factor of x minus 5 being squared. So I'm going to do the square root property. And what I'm going to do is go ahead and isolate my term that is being squared. So I would move my 9, and then I would square both sides. And I'd get plus or minus 3 equals x minus 5. I need to isolate my variable, get it alone. So I would move my 5, and I would get 5 plus or minus 3 equals x, which means my x is 8 and my x is 2. So as far as coordinated points are concerned, I've got 2 minus 0 and 8. I didn't mean to say minus. 2, 0 and 8, 0. So, and 8, 0. Okay, now let's do the y-intercept. The y-intercept, what we do is we plug in 0 to our function. So I would get f of 0 equals, that's going to be a negative 5 squared minus 9. F of 0 equals 25 minus 9. F of 0 equals 16. So that's the coordinated point 0, 16. Right here, 0, 16. Okay, so it's also going to ask me for my domain, and I know that that's a polynomial, and so my domain is going to be all real numbers, and it's going to ask me for my range. I can't just, pull the range out of thin air. I'm actually going to need to graph this, and then I can tell you what the range is. So let's go ahead and graph this. I'm going to start with that first point that I found out, which was my, my vertex, and it was 5, negative 9. So I'm going to go to the right 5 and down negative 9. And I end up right here. I end up right there. Okay, now what do I know? I know that my A was equal to 1, which is greater than 0, which means it opens upwards. Okay, so that is telling me that it's going to do this because my A is greater than 0. If it was less than 0, it would be going the other direction. It would be opening downwards. If I keep looking, I know that my line of symmetry is going to be at x equals 5. I don't really need to know that just yet. I know that I found my x-intercepts and my y-intercept. My x-intercept is 8, 0. So I'm literally going to go to the point 8, 0. Let me zoom in here because y'all have that written down already on your notes. 8, 0 would be right here. And then 2, 0 would be right here. And then I also learned that my y-intercept was 0, 16. So I'm not moving at all on my x, but I am going to go up to 16 on my y. And now that I have these 3 points, I can actually graph this parabola. It's probably going to be really ugly, but it's okay. So I know that this is going to go this way, and then of course my hand started to shake. Very shaky. should look like this, but I don't trust myself when drawing a parabola. I don't trust myself when drawing a straight line. So hopefully that kind of makes sense. I do have one graphed already for you that I'm going to show you. And so now let's do our range. Our range are our y values. And so you would get your pencil. Okay, so red is my domain. And then we have our light blue. That's our range. So looking at this, I noticed that at -9, that is the lowest point on my y-axis. And so that would be where my range begins. And you do brackets there at -9. And then it goes forever in the positive direction, which is a positive infinity. Okay, so let me show you these. Let's go ahead and check our x minus 5 squared -9 right here in the green. This is those are our points that we plotted, was a 5, 9, 5, -9, and then 8, 0, 2, 0, and then this point right here, 0, 16. Okay, so the decimal, I have 3 different things here, and it's calculating where it crosses. That has nothing to do with this problem. And then there's our 8, 0, and then there's our 5, -9. Now, for the first problem, I'm sure y'all believed me whenever I told you that the vertex was +1, -1. So that's 2x minus 1 squared, and then a -1. And I'm saying the vertex is +1, -1. That is this first graph right here. And I notice that my vertex is a +1, -1. And then now let's look at this graph right here, where I was trying to tell you that because in the formula in that function, my 6 was positive, I would have had to have used a negative to make a positive with the formula. So my vertex was -6, 7. So just to confirm that I wasn't lying to you, that is -6, 7. And if you notice in this formula, why do I keep saying formula? In that function right there, my leading coefficient, my a was negative. And so do you see how the parabola opens down? And that's it, y'all. Let me know if you have any questions, okay? Thanks. Bye.